Hi everyone, welcome back to Viera Edge. In today's video, we're going to talk about breadboards, how they work, how we use them, and we're also going to make a few simple circuits with this breadboard. And before we start this video, I have a small fun fact. The reason these are called breadboards is because they literally were breadboards. So in the early 1920s, radio nerds would take actual bread cutting boards. They would take these cutting boards and they would hammer nails or use thumbtacks and screws, and these would act as anchor points. And then they would take wires and they would wrap them around these anchor points and solder them. And then these wires would then, of course, connect all the components with each other. And that's basically how they made circuits back then. And you can imagine just how time-consuming that is. And we're very lucky because breadboards now are so simple to use. Look, I just made a connection. I just took it apart. So I hope that by the end of this video, you guys can very easily use these breadboards and all of you also understand how these things work. So here we have a breadboard. Some may look shorter, some may look longer, some might not come with these labels or colors, but they all basically work the same. So there are two main zones in a breadboard. The first zone is the power rails on the sides here. These are long vertical strips marked with positive and negative, and we usually use them to distribute power. So how they work is that all the holes in a single vertical column are connected together. So we see here, all the holes in this negative column are connected together, and all the holes in this positive column are connected together. So that's the first zone. The second zone, the center area here, is what we call terminal strips. Usually they're labeled with letters and numbers. So letters show the columns and numbers show the rows. And how they work is that these holes here are connected horizontally in groups of 5. So let's go to row 10 for example. So holes 10A to 10E, they're connected in a group of 5. And you can see here, there's this gap. We call it a middle divider. And basically what this does is that it shows that holes 10A to 10J, although they are connected to each other, they are not connected to holes 10F to 10J. And another thing to also know is that there is vertical isolation in these terminal strips. So row 1 here, row 1 and row number 2, they are completely separate. Now all of these things, they may be confusing to you, and I understand. So what I'm actually going to do is here, I open the back of this breadboard, and now you see here all the metal strips that are behind this breadboard. So all of a sudden, it's a lot easier to visualize how these holes are connected. So before I said for the power rails, all the holes in a single vertical line are connected. And you see here, there's a long strip of metal going from top to bottom. So that's why, and that's how these holes in this singular vertical line is connected. And if you look closely, these two vertical lines are separated by a tiny gap. And that's why all the holes in the negative column is not connected to all the holes in the positive column. Same as for the terminal strips. You see here, all these shorter horizontal metal strips, they connect the holes in groups of 5. But here, there are tiny gaps between these strips, right? And that basically shows why there's vertical isolation, why row 1 and row 2 are completely separate, and why the holes in row 10 on the left here is also separate from the holes in row 10 on the right. So I hope that with this, you guys can more easily visualize how breadboards actually work. And now I'm gonna start making a few simple LED circuits. So now we have 3 LEDs, 3 wires, the breadboard, and my power source. Right now my power source is only 3 volts. And the first circuit that I want to make is the parallel circuit. Now we remember that just now we talked about the power rail. Usually we use them to distribute power. But since we know that basically we can imagine this negative column as one long wire and this positive column as one long wire as well, there's actually a very easy and simple way to make a parallel circuit. And it's basically, we just need to directly insert the LEDs on the power rails. So let's look at this LED first, okay? There's this longer leg and a shorter leg. Now this longer leg shows that this is the positive side and the shorter leg is the negative side. If we look even closer on the LED itself, this longer leg is connected to this smaller body and this shorter leg is connected to this fat body. So one easy way to remember which is positive and which is negative is that the fatter body is negative and the smaller head is positive. So let's make our first circuit, the parallel circuit. So I'm just going to directly put the positive leg on the positive column and the negative leg on the negative column. I'll do the same for all the LEDs. It's very simple to just put these LEDs in. And we're done. Simple as that. Now, since we can basically imagine this negative column as one wire and this positive column as one wire, all we need to do to finish or complete the circuit is just to put in the power sources. So I'm going to put the ground in first on negative, and then here I'll put the voltage source in 3, 2, and 1. And done. It's all on. So it really is as simple as that. So this is our first circuit, the parallel circuit. Now for the second circuit that I want to make, of course, it's the series circuit. But as we all know, we need more voltage for a series circuit. So here, we're using 3 LEDs. For the series circuit, we're only going to use 2 LEDs. Okay, so then let's start. So power rails to distribute power. Okay, let me take voltage. Okay, and I'm going to distribute this voltage to, let's say, row number 15. I place it on row 15, column J. Okay, then let's take this green LED first. Positive leg on row 15 and row 15, column H, and then the negative flag on row 16, column H as well. Hold on, it's a bit stuck. There you go, now it's in. Okay, then for a series circuit, let me put this positive flag on the same row as the negative flag of the first LED. So same row, that's row 16. let me put this positive leg on row 16, column F, and then the negative leg on row 17, column F as well. Okay, so right now we're almost done. So what we want to do is we want to add a ground to this negative leg. This negative leg is on row 17. So I'll just pick any random hole on the same row, on the same side. Remember, since there's this middle divider that divides this row and this row, so make sure it's on the same side. And here, I'll just put the ground on the negative column. And now we're finished. Now all we need to do is to put in the voltage sources. But remember earlier I said the voltage source is only 3 volts? Well, since this is series, we actually need a higher voltage. So let's see what happens if we put a lower voltage first. So ground in, and now voltage source in 3, 2, and 1. Well, it's not on. Well then, let's increase the voltage from 3 volts to 5 volts in 3, 2, and 1. And now, it's on. Really is just as simple as that. So these are the 2 circuits that I wanted to teach you guys today. And I hope that this video is beneficial. And if you did find it interesting or helpful, please share it with your friends. And if I do make any mistakes, then feel free to leave it in the comments. Well, thank you for watching the video, and goodbye.